Aromatic aldehydes, ketones and quinones. Properties of benzaldehyde. Leave a few drops of benzaldehyde on a watch glass exposed to the air for a few days during a pinch of starch with a few cubic centimeters of cold water and pour the mixture into about 15 centiliters of boiling water. Cool and dissolve in the solution of a crystal of potassium iodine and divide the solution into two portions. Shake one of these with 2 drops of benzaldehyde and expose both to sunlight for some time and explain the results. As far as the test for the aldehyde groups in benzaldehyde, shake up a few drops of benzaldehyde with about 15 centiliters of water and test parts of the solution with the filling solution. Tolerance reagent and shifts reagent. Compare the results with those obtained with acetaldehyde. For the test with the phenyl hydrazine, see experiment 192D, page 163. If this experiment has not been performed, do it now. Benzaldehyde and sodium hydrogen sulfite. Shake about 1 centiliter of benzaldehyde with 5 centiliters of a saturated solution of sodium hydrogen sulfite. Filter off the crystals by suction and wash them with a little alcohol until odorless. Dissolve the crystals in warm water. To 1/2 of the solution, add a solution of sodium carbonate and to the other dilute sulfuric acid. Explain the cause of the appearance and odor produced. As far as sodium hydroxide and benzaldehyde are concerned, shake up a few drops of benzaldehyde with a solution of sodium hydroxide and then warm the mixture. Is a resin formed and compare the result with those obtained in the case of acetaldehyde. For the behavior of benzaldehyde with alkalis, experiment 193. Benzaldehyde and ammonia hydrobenzamide mixed together 3 centiliters of benzaldehyde, 20 centiliters of alcohol, and 10 centiliters of a concentrated solution of ammonia. Set aside the mixture until the product with separates become solid. Heat on the steam bath and add alcohol until the solid dissolves. Set aside to crystallize. Determine the melting point of the crystals. Compare the behavior of formaldehyde, acetaldehyde, and benzaldehyde with ammonia hydrobenzamide. Crystals form alcohol in octahedral with melt at 110 degrees. Preparation of benzophenone in a dry 500 centiliters flask. Put 28 grams of benzene, 30 grams of anhydrous aluminum chloride in the form of lump, and 27 grams of benzoyl chloride. The aluminum chloride should not be exposed to the air any longer than necessary, as it rapidly absorbs moisture. Attach to the flask by means of a cork, a small drying tube containing anhydrous calcium chloride. Place the flask under a hood in a beaker containing water and let the reaction proceed for at least 24 hours. To determine whether the reaction is complete, pour a few drops of the material into a few cubic centimeters of water in a test tube. Shake the tube and observe whether the characteristic odor of benzoyl chloride is present. If the chloride is present, the mixture should stand for several hours and then be tested again. When benzoyl chloride can no longer be recognized by its odor, pour into the flask rapidly a mixture of 200 centiliters of water, 100 grams of shaved ice or snow, and 15 centiliters of concentrated hydrochloric acid. Shake under running water until 2 layers are formed. Add 15 centiliters of benzene and separate the solution from the acid. Shake the former with a solution of sodium hydroxide to remove any benzoic acid that may be present. Try the solution with calcium chloride and filter it into the distilling flask provided with a thermometer. Distill using water condenser until the temperature of the vapor reaches 215 degrees. Replace the water condenser by an air condenser and collect in a weighted 200 centiliters. Bag the material boiling between 218 105 degrees and 305 degrees. Record the weight of the distillate, which should change to a mass of crystals dissolved in warm alcohol, 5 centiliters of each gram of benzophenone, and add to the cooled solution cold water until a permanent cloud is formed. The volume of the water used should be about 1/3 that of the alcohol. After standing overnight, filter off the crystals and add water to the filtrator as before. Weighted 2 crops of crystals, calculate the yield, determine the melting point of the crystals. Benzophenone melts at 28 degrees and boils at 306.1 degrees. Corrected. The yield in the preparation is about 25 grams. Preparation of benzophenone oxime. In a flask provided with a reflux condenser, dissolve 5 grams of benzophenone in 5 centiliters of alcohol and add a solution of 5 grams of hydroxyamine hydrochloride in 15 centiliters of water. To this add a solution of 10 grams of sodium hydroxide in 15 centiliters of water and heat the mixture on a water bath for an hour. Put the product in about 200 centiliters of water if necessary and add to the filtrated dilute sulfuric acid until the solution is just acidic to litmus paper. After an hour, filter off the benzophenone and weight the product when dry. Calculate the present yield, which should be nearly theoretical. Crystallize the oxime benzophenone and melt at 141 degrees. Beckmann's rearrangement of an oxime. In a small flask, dissolve 2 grams of benzophenone in 13 centiliters of ether dried over sodium and add slowly in small portions 3 grams of finely divided phosphor pentachloride. At first, it may be necessary to cool the solution. Toward the end of the reaction, the mixture should be heated on the steam bath until the phosphorus pentachloride has dissolved. When this has taken place, pour the health solution with vigorous stirring into 400 centiliters of cold water. Stir until the solid has formed and then filter it off by suction and wash with cold water. Crystallize the benzanylate from the smallest amount of boiling alcohol and determine the melting point of the dried crystal. Write equations for the reaction involved in the rearrangement. Benzanylate melts at 116 degrees. Preparation of quinone. The procedure is that you mix a large beaker 215 centiliters of water, 15 centiliters of pure concentrated sulfuric acid, and 15 grams of sodium bichromate, or the equivalent weight of potassium bichromate. When the salt is dissolved, set the beaker in cold water and cool sodium to 20 degrees. Mix in a beaker 115 centiliters of water and 10 grams of aniline. Pour into the mixture with stirring 10 centiliters of pure concentrated sulfuric acid. Cool the solution to 20 degrees and added stir vigorously in 4% to the solution of sodium bichromate. The beaker in which a reaction takes place should be surrounded by cold water and the temperature should be kept between 35 degree and 14 degree. About 6 to 8 minutes are required for addition of the solution of aniline sulfate. When this has been accomplished, remove the beaker from the water and let it stand for about 15 minutes. Transfer the product to a large flask and cool it in running water to about 15 degrees. Add to the flask, Add to the flask 300 centiliters of ether and shake. Let the flask stand for a few minutes in order to facilitate the separation of the ether into a distinct layer. Add to it 25 centiliters of acetone and give to the flask a central rotary motion. In a few minutes, decant off carefully as much of the ether as possible into a separatory funnel. If some of the aqueous layer flows into the funnel, it can be separated. Draw off the ethereal solution, place it in a flask, and distill the ether from a water bath throughout a long water jacket condenser. Extract the solution of quinone once more with the recovered ether and evaporate it off as before. Crystallize the residue of quinone from the smallest possible amount of boiling liquor or distill it with steam in the ordinary way, except that no water is put into the flask containing the quinone. Dry the crystals of quinone in a desiccator. The compound is volatile at room temperature, and if left exposed to the air for a number of hours, an appreciable quality is lost. Quinone nuts at 116 degrees centigrade, the yield in this preparation is 5-6 grams. Properties of quinone are, for example, reductionability of the quinone. To test it, you shake up a crystal of quinone with 10 centiliters of water. Note the odor and color of the solution. Add to 1/2 of its solution of sodium hydrogen sulfide. To the other half, add a dilute solution of potassium iodide and a few drops of dilute hydrochloric acid. Use a solution of quinone. Dissolve a few crystals of quinone in 5 centiliters of carbon tetrachloride and add drop by drop a solution of bromine in carbon tetrachloride. Formation of quinhydron. Make a saturated solution of quinone in water and add to the solution drop by drop a strong aqueous solution of hydroquinone. Examine the tube after about 1 minute. If crystals have not formed, repeat using a more preparation of anthraquinone in a 215 centiliters round bottomed flask provided with a condenser plate, 5 grams of anthracene and 15 centiliters of glacial acetic acid. Heat the liquid to boiling over wire goes and add drop by drop from a separate funnel placed in the upper end of the condenser solution made by dissolving 10 grams of chromic acid and drilled in 10 centiliters of water and then adding 25 centiliters of glacial acetic acid. Boil the solution for 10 minutes after the oxidizing agent has been added and then allow the mixture to cool spontaneously to temperature of the room. Finally cool under running water. Filter by section and wash the crystal twice with a mixture of 2 volumes of water and 1 volume of glacial acetic acid using 20 centiliters of the mixture each time. Finally wash twice with water and allow the crystals to dry in the air. Sublime a small amount of the dried anthraquinone and crystallize it from boiling alcohol. Anthraquinone sublimes at about 215 degrees in yellow needles, which melt at 273 degrees. The yield in this preparation is 5 grams. Boil together for about half a minute. A trace of powdered anthraquinone with a little zinc dust and 10 centiliters of solution of sodium hydroxide. Filter the solution and shake it with air. Anthraquinone is partly reduced by zinc and sodium hydroxide to a red salt of decomposition. The salt is oxidized by air to anthraquinone. The reaction is a valuable one in the identification of this substance. Compare the properties of anthraquinone with those of benzoquinone. Thus, the former oxidizing an acidified solution of potassium iodide is reduced by sulfurous acid. Note that after oxidation by chromic acid in acetic acid solution, the product is used as precipitate by pouring the solution into water. In the case of anthraquinone, it is convenient to allow the mixture to cool as the compound crystallizes well from glacial acetic acid. Aromatic, no, it's another subject, sorry, it's the rain.